Hello and welcome back to Higher Maths, the circle. Today we're going to look at lesson number 3 on the circle, intersection of a line and a circle, finding out when a line meets a circle. So a straight line and a circle can have 2, 1 or no points of intersection. So here it can cross into the circle, as in this example here. You could have 1 point of intersection, so if the line's a tangent to the circle, or there can be no points of intersection where the line just passes by the circle, so to speak. So as I just said, if a line and circle only touch at 1 point, then the line is a tangent to the circle at that point. So let's have a look at an example. Find the points where this line intersects the circle with the equation x squared plus y squared equals 20. So to do this, guys, we would use substitution. So I've got an equation involving x and y. I know y in terms of x. So a quick sketch. I know this will be a circle with centre 0, 0 and a radius of the square root of 20. So I'll sketch there. I know from y equals mx plus c that this will have a gradient of 3 and will also pass through the origin. So I know it's going to cross at 2 places. Okay, so just done a little sketch, just have a think about what's going on there. Quite often that's handy. So again, I know y in terms of x. I'm going to substitute y equals 3x into this equation of the circle. So we're doing 3x all squared, so that will be x squared plus 9x squared, so 10x squared equals 20. Divide through by 10, square root. Remember, guys, we're looking for 2 solutions here. We're looking for this point and this point. So remember to take the positive and negative square root of 20. Now, I have the x coordinate. I would like the y coordinate as well. I know the y coordinate is equal to triple the x coordinate. So when x is root 2, y will be 3 root 2. When x is negative root 2, y will be negative 3 root 2. So there are the 2 points of intersection of the line and the circle. So a bit of substitution, and there it is. Question number 2. Find the points where the line with the equation y equals 2x plus 6 and the circle with this equation intersect. So again, quick sketch, just to have a rough idea what's going on. It does say in the question, find the points. So that's suggesting it's going to cross at 2 points. If it said find the point, I'd be looking for a tangent. So I know y in terms of x, so I'm going to replace any y with 2x plus 6. So again, I'm just substituting in here. So substitute in, expand the double bracket. So guys, if you can do that in your head and you get it correct 100% of the time, feel free. If not, bracket bracket. So we do have 24x in the middle here. We cannot just square 2x and square 6. That does not work. Tidy up. I've got 5, 30 and 40, so look for a common factor. And then we are just factorizing a trinomial with a unitary power of x squared, which has got 1x squared, which is normally quite straightforward, and all the terms are positive, which is even nicer. So 5 bracket bracket, so x plus 4 equals 0 would lead to x equals negative 4, x plus 2 equals 0 would lead to x equals negative 2. Find the y coordinates to go with the x coordinates, and that is us done. Okay, so looking at the original graphs, that would be negative 4, negative 2, that would be negative 2, comma 2. So all we're doing, guys, substituting and solving. So not there's an idea there, there's a new idea, but there's not actually any new maths. We're just applying our previous knowledge in a new context. Right, tangents to circles. So as mentioned about 4.5 minutes ago, if a line just touches a circle, it will be a tangent. Okay, so example here, show that the line with the equation this is a tangent to the circle with the equation this. So again, we'll just need to substitute in, so I'm going to have to rearrange x plus y equals 4 to make either x or y the subject. It doesn't really matter which one. So I'll go for y equals 4 minus x. So I'm going to substitute in, expand the brackets, and we get down to 2x squared minus 4x plus 2 equals 0. Right, all we're asked to show is that this line is a tangent. There's two different ways of doing this. Okay. Personally, I would just do it this way all the time. Okay. Unless we get something that is really, really tricky to factorize. So we've gone down to this point, take out a common factor. Now, as there's just one point of contact, we're looking for a repeated root here. We've got two roots. It's just touching one, so we should be getting a repeated root, which we do. So again, common factor out, factorize, so we get x equals 1, x equals 1. So a repeated root, therefore one point of contact, the line is a tangent to the circle at 1, 3. So where did the 3 come from? I just substituted x equals 1 back into y equals from above. Right. If the point of contact is required, this method is more efficient. So if we're asked where that point of contact is, we're going to need to do this anyway, so just choose this. Okay. What we could have also have done at this stage, we could have looked at b squared minus 4ac, and if that is equal to 0, then that will give us a repeated root. Therefore, the line will be a tangent to the circle. So substituting our values of a, b, and c, we do indeed find that it is equal to 0, and then we just need to make our statement afterwards. Again, generally speaking, guys, you are asked to find the point of contact, so I would do it this way most of the time, unless it's something really nasty that doesn't really factorize too well. Okay. All right, one more question. Equations of tangents to circles. So let's have a look. So here we have the radius. We know the radius makes a right angle with the tangent from National 5. So if I knew the gradient of my radius, I know that if I multiply that by the gradient of the tangent, I'm going to get -1. As they are perpendicular, so back to straight line knowledge, or if I knew that gradient, I could basically, if I know the gradient of the radius, I can basically flip the equation of the radius upside, the gradient of the radius upside down, multiply by -1 to find the gradient of the tangent. So it's a negative of the reciprocal of the radius, if we're using the correct language. And then once we've got that, we've got a point here, we've got the gradient here, we're just y minus b equals m bracket x minus a. So let's go through an example. So show that the point 1, 3 lies on this circle and find the equation of the tangent at a. Right, so first of all, we need to show it lies on the circle, so substitute in x equals 1, y equals 3. And if it equals 0, then that means that it lies on the circle. So substitute in, evaluate, it does indeed come out with 0. So that means the left-hand side will equal the right-hand side, so that point will lie on the circle. So 1, 3 lies on the circle. From here, we can find the centre. Okay, so the centre will be 2gx equals 2fy, so the centre 2g will equal 6, so the centre will be -3, -1. Remember that the centre is given by -g, -f. So you guys have had a lot of practice at doing that. It is actually okay just to look at those, half them both, change the sign, and state that that's a centre. Okay, so we've got the 2 points here, so we can find the gradient, which is what we're doing here. So the gradient of the radius is 1. So again, to find the gradient of a line perpendicular to that, in this case the tangent, we multiply by the gradient of the radius by the reciprocal of the radius. Basically, we turn it upside down and multiply by the negative. So if we flip 1 upside down, we'll still get 1. Multiply by negative gives a gradient of -1 for the tangent. So the equation of the tangent, we have the gradient, we have a point, on that tangent. Remember, we can't use C, because C doesn't lie on this straight line, so we can't use it. We've got to use A. Substitute into y minus b equals m bracket x minus a. And there we have the equation. Right guys, as always, have a go at the questions. So exercise 14C, these questions here.